Hello friends, this is Praveen. Welcome to online course on Python basics. In my last video, I have discussed about dictionary data type in Python. Today, I am going to discuss about operators in Python. So what is an operator? An operator Operators are used to perform operations on variables and values. And in Python, operators are divided in following 7 groups. Arithmetic operators. These operators are used to perform mathematical operations like addition, subtraction, multiplication, division, etc. Second is bitwise operators. Bitwise operators act on operands as if they were string of binary digits. They operate bit by bit. So the value or variable is first gets converted into bit, and then they work on the bits itself bit by bit. Assignment operators are used in Python to assign values to variables. Comparison operators are used to compare values. It returns either true or false according to the condition like equal, double equal to, greater than, less than, etc. Then logical operators are used to combine conditional operators. Identity operators. These operators are used to check if two values or variables are located on the same part of the memory by the interpreter. Membership operators. These are used to test whether a value or variable is found in a sequence like string, list, tuple, dictionary, or cite. Now let us see it one by one. First is arithmetic operators. So what are the operators available in Python in this group? So first is plus, minus, multiplication, division, modulus. Modulus is for remainder, exponentiation, and then floor division. So let us take it one by one in our spider IDE. So this is our spider ID, and we were working on this page dictionary.py. So now we'll make another file, so new file, and I will save it using giving a name operators.py. Save it, and now we need two variables to work mm, to work with that. So either we can declare x is equal to 15 and y is equal to 10, or we can take two inputs from the user. So how we can take the inputs? We can use two different input function. We use input function input to take the x input, and other is input. And since by default this input is takes the value in accepts the value as a string. If we check here, I will just check one, x is equal to input, and we need to tell though the data I inserted is an integer. If we check type of x, it will return a string. So it is a str. So we need to convert this input back into int form so that we can perform our arithmetical uh, operations. So int we will convert back into integer, and then int. That is what we can do here. Int, and now we have two variables, and we can pass x for 15, enter, and then for y I'm passing 10. So this one, if I print x comma y, so it will give you 15, 10. So it is printing. So what if we want to take both inputs in same line? Then we can do that as well. just separate them x comma y, and in this case we cannot use this int, since when we use multiple inputs using input, so it accepts all the inputs as a list. So dot split, so what will happen, it will take two inputs, or you can pass as many inputs as you want, just you need to xyz. So three inputs, you need to separate all the all the inputs using space. So let us take it, I'm just passing two inputs right now, control enter, and I'm passing 25 space 20. So x is 25, y is 20. We try to print this one, so 25 and 20. What if I try to check the type of x or y, type of x? So this type is str. So we need to convert it back into integer to work with the this data on these variables x and y. So x is equal to int x, and then we will convert back into, we will convert y as well, int y, control enter. Now the data type of this x and y is int integer. Now we can work all these arithmetic operations on these two numbers. So let us take it now. So first is we have x plus y. So output should be 45. 45 x minus y, and output should be 25 minus 20. That should be 5 x star 25 star 20. 25 multiplied by 20 is 500. If we divide 25 by divided by 20 is 1.25, and if we use our modulus operator, that is the remainder, so remainder 25 divided by 20, remainder will come 5. And if we use our exponentiation, so in this case what will happen, 25 and 20, it will become a very large number. We can check it here, 25 to the power 20. So this comes very large, so I will assign a smaller value. Again, x is equal to 4, y is equal to 2. I'm just assigning this thing. Okay, so this one, and if we check, it should come 16. So this is how we can use. Now we have a floor division. So what is a floor division? Let us take it. So I will just assign something here, 5. So now x is 5, y is 2, and I will use this floor division. Or rather, first we will check this division first, then we will check the floor division. So division, it is returning 2.5. What if I make floor division? It is returning 2. So float division is a normal division operation, except that it returns the largest possible integer. This integer is either less than or equal to the normal division result. So right now it is less than. When it will become equal? When this numbers are exactly divisible. So this time this x divided by y is 2, and then x floor division y is 2 as well. The only difference is when you make simple division, the return type is a float, but when you make a float division, the return type is an integer. Now get back to our presentation. So next is we have bitwise operators. So Python has following bitwise operators and we use this AND symbol. Then OR, we use pipe symbol. XOR, we use caret sign. Not, we use tilde character. And then zero fill left shift, we use two less than angular bracket sign. Signed right shift, we use two greater than angular bracket sign. So let us take it one by one in our IDE. So next we have bitwise operators. Bitwise operators. So what will happen here? Suppose we have x is equal to 14 and y is equal to 17. And if we want to do our bitwise operations like x and y, so what it will return? Let us take it. Control enter. So x and y is not defined. Y, okay, y is capital. So it should be in lowercase. Then it will get defined. Now you check. So output is 0. Why is this? Let us take it first. So what will happen here? This x will get converted into equivalent binary input. So the binary number equivalent to 14 is 1 for 8 for 12 to 0, 1110, and for 16, or we can write this as well, this. So this is your 14. What if we want to convert this 17 to binary equivalent as well? So here what will happen? 0 0 0 1 0 0 0 1. So now the output, when you add two values or two bits, then output will be high only if both of the inputs are high, or you can say if both of the inputs are 1. So in this case, what is happening? This 0 1, the 0 1 is returning 0. Let us come here. 0, then again 0, sorry, 0, then again 0. Now 0 1, only one input is high, so 0, again 1 0, one input is high, 0 1 0 0 1 0 0 0 1 0. So all this, the output is only 0, that's why it has come to 0. What if I change the value from 17 to 18? So the moment I change it to 18, the equivalent binary will become like this, 1 and 0. And what will happen here now? 0 0, and this here we have ones in both x as well as y. So what will happen here? We'll have 1. Now this two inputs x and y both are 1, so output will be 1 and then return value should be 2. Let us take it. I'll just enter this one, y is equal to 18, and if we do this thing now, so it should come 2. It is 2. Now next is we have OR. So if we use OR, so to make OR we use a pipe symbol. So pipe, and then now in this case pipe, either one of the inputs is high. What will happen? Suppose I'm just removing this here, control enter. So this will not be played here. So if we do this one, let us take it here. So the input is 30 now. 14 or 18 is 13. So let us take it here. So what will happen? 0 0, both of the inputs is low, so it will output will be low, again low, again low. But now you say one of the input is high, so output should be high, then again high, then both of the inputs is high, so again high, and then 0. So now the output is 0 2 4 6 8 2 4 6 8 14 and 16 30. So that's why the output is 30. So this is about or either of the input is high or both of the input is high. So output will be low only if both the inputs are low in the case of OR operator. Next is we have XOR. So in this case we have XOR. Earlier in the case of OR we have seen this 1 1 was coming 1, but in this case with XOR exclusive OR it is coming 28. Why is this? Because here 0 0 0 0 0 0 0 1 only 1 is high, 1 0 only 1 is high, 1 0 only 1 is high, but here 1 1 both are high, and in the case of XOR only either one of the input should be high, not both of them should be high, so it should be 0. And if you convert this binary into equivalent decimal number, it will come 28. So that's why this is XOR operator. Next is we have NOT operator. So what it will do, it will take here, so NOT tilde up character and X, control enter. So it is returning 15. So minus 15 rather. So what it has done, when you actually convert this 14 uh, to not of this, then it will just make 2's complement. It returns 2's complement of that value. So what is a 2's complement? So for 2's complement, first you need to convert into 1's complement. So 1's complement. So let us take it first. Let us take it here. So 1's complement, you need to change every the digits, or rather bits. So 1 1 1 1 0 0 0 0, and then you have to convert it back, add 1. So just add 1 more. Let me convert here to 1 1. So it will come 1 1 1 1 1 1. So this is equivalent to minus 15. What is happening in this case, that our computer does not accept negative numbers, so it makes suitable binary digit, or it is the 2's complement of the number. So suitable binary numbers to insert that negative number. So this is equivalent to minus 15. So what will do if we change this, if we want to get back our 14? So we can do one more not, and then, or we can save it into some another variable. Z is equal to not X. control enter. So this one, now z has got 15. Z, to let us print z minus 15. So if we try to uh, get not of z, it will return back you the x. So let us take it here, dollar $x, this tilde z, not of z, so it is returning 14, and this is x 14. So this is just 2's complement of the value. Next is we have zero fill left shift. So what if we try to do this one? Z is equal to x 2. So what will happen here? Let us check the output, then I will show you the how this output has, we have arrived at this output. So control enter, and if we see what is the value in this z, so it is 56. So what will happen here? This is the value. If we add x 2, it means 2 digit, it will shift 2 digit left, and it will insert two zeros. So what will happen here? 0 0 triple one 0 and double 0. So it has changed. This this digit has got shifted left side with, and added two more zeros. So the equivalent value is 56. If you calculate this, it will come 0 2 4 8. So 8, 16, and 32. So 32 plus 16 plus 8, it comes 56. So it comes 56. So how it comes, how we can get to know this value will come? So this x double binary zero fill left shift equivalent to, if we write this, then it is equivalent to x is equal to x is equal to, or we can say it is equivalent, if we assign something it is equivalent to some x star to the power y. So this is equivalent, this x uh, zero fill left shift is equivalent to x multiplied by 2 to the power y. So this is equivalent path of this. So if we shift the value 2, so 2 is like this, and if we write 14, so this we have used, so this will come exact 56. So this is what this zero fill left shift is. Now another is signed right shift. So in this case, what will happen here? I'm just making one more. Z is equal to, sorry, z is equal to x, and then q. What will happen here now? Control enter, and if we check what is the output in this z, what this value, what this z variable stores, so it is storing only 3. So x is 14. So if we do this x 2, so what it does, it just fills 2 digit at the left side, 0 0 0 0 2 bits, 2 0 bits, 0 0, then 0 0, and then it makes 1 1. So this is how this 2 bits has got shifted and in to right, and in the from left side 2 more zeros has been inserted. So this one has become 3. So it is equivalent to this x. We can say if we use in place of 2, if we use y, then it is equivalent to this is equivalent to x floor division to the power y. So what if we change this here? So what will happen here? We have got 14. Okay, let it be like this. We'll change here. So x is 14 divided by 2 double star 2. So it should come 3. So this 3. So earlier when we use z is equal to x sign right shift, it returned 3. And same thing if we used this operator x float division floor divided by 2 to the power y, then the same thing. So it is equivalent. Next is we have assignment operators. So let us take it. So assignment operators we have equal to, plus equal to, minus equal to is simple assignment, and rest all are augmented assignment. So equal to we can assign some value to some variables, then plus equal to, minus equal to, star equal to, forward slash equal to. So let us take it one by one here in our IDE. So first we have some values. So we'll use x is equal to 14. So this 14 is assigned to x. If we check x, this value will be assigned to x. Now we can assign some value. Suppose x is equal to, if we can assign x is equal to x plus 10. So this we can do. So what will happen? The value of x will become 24. 24. And the same thing we can write like this, plus equal to 10. So this time what will happen? The value has changed from 10 to 24. Now if we execute this thing, so x is equal to x plus 10. So it will become x is equal to 24 plus 10, and the output will become 34. And if we check this x, so it will be 34. 34. And similar to this we have negative equal to 10, and this time it will go back to 24. 34 minus 10, 34 minus 10, so this will come back to 24. Now we have multiplication like that, star equal to 4. So 24 into 4 is 96. 24 into 4 is 96. So this is 96. If we do with division equal to 4 6. So this one, what will happen? 96 divided by 6 is 16. So if we check it here, x, it should be 16. Yes, 16. Next we have modulus. Modulus equal to 6, or we can do whatever we want, 6. So 16 divided by 6, modulus will remain to be 4. So if we check x, the output should be 4. 4. Next we have floor division. So if we do floor division, sorry, floor division equal to 3. So what will happen now? X is equal to x floor division 3. So the value will become 1. X, the value will become 1. Next we have the power. So let us take it, I will assign some more value here. X is equal to 2. Otherwise, if we raise any power to the 1, it will become 1 only. So that's why I'm changing the value. X is equal to 2. Now if we do our this power, so x double star, sorry, double star equal to 3. So it will return x is equal to x to the power 3, x to the power 3, so 2 to the power 3, it will become 8. So x, it should become 8. Now likewise we have x and operator is equal to 4. So it will x and 4, x is equal to x and 4. And if we check this x, it is 0 because 8, x was 8 and now we are appending, so x was 8, and we are doing and with this, sorry, let me check, 0 1 double 0. So everything in none of the bits is high simultaneously. You can see here, this is 8, this is 8, and this is 4. So 0 0 0, if you AND it, 0 0 0, again 0 1 0 1 0 0. So this is the output 0. Now similar to that we can use x is equal to 0. So I will just change x or equal to 4, or we can do 3, whatever we want. Control enter. So the output should become 3 because anything, the output is 3 because either one of the input. Next, similar to this, we have XOR. XOR is equal to 2. Now if we check the XOR, it should become 1 because it is 3, earlier it was 3. So this means 3 or 2, x is equal to, and this means x is equal to 1 1 or XOR 1 0. So this 0 and 1 is 1. This 1 1, path is high, so it will return 0 and the output should become 1. X, the output should become 3. Let me check why it is this. Y x to the power x3. Let me check what is happening here. X is what? X is 3, right? 1 1, then 1 0 1, right? right. It's a one now. Now it is one because probably that was not got, that statement did not got executed. So now it is one. And likewise, we have this zero fill left shift as well as zero fill right shift. So if we do here X and then we use this one, this left shift equal to 2. So 2 to the power 4, 1 multiplied by 2 to the power 2. So it will return you 4. So 4. And likewise, the signed right set 1. So it will return 4 divided by 2 to the power 1 is 2. If we check it, X, it should return 2. So this has become 2. Now next is we have comparison operators. So comparison operators, these are used to compare values or variables. So double equal to if two values or variables are same, not equal to, if they are not equal, it will return true. If they are not equal, if they are equal, it will return false. Greater than, if two numbers are greater, one number is greater than another number, then it will return true. If one number is less than another number, it will return true. Greater than, equal to. So let us take it here one by one. So we will assign some values. X is equal to 8, y is equal to 7, and I'm just control enter, and I will check this double equal to equality x double y. Since, so it is returning false since the numbers are not same. So I'll just make the numbers same, and then we'll check x double equal to y. It should come true. So it has come true. Now what if we check not equal to, x not equal to y, and this time it should return false. It is returning false. I'm changing the number. So let us execute it, and then if we check, it should return true. So this is true. Next we have greater than. So if x is greater than y, x is greater than y. No, 7 is not greater than 8. So it should return false. Now what if we check less than? So it should return true, right? What if we try to do this less than and equal to? It is again returning true. What if I make it to 8? It will return true again. It is returning true. And if I make this, change it to greater than, x is greater than, no, so it is returning false. But if we check greater than equal to, so in this case it will return true. It is greater than or equal to, x is not greater than but it is equal, so it is will return true. X is greater than or equal to y, it's a return true. Let me check it. Greater than equal to, let me execute it first, then it should return true. Yes, it is returning true. Now get back to our presentation again. So next is we have logical operators. So these operators are used to combine conditional statements. And suppose we have two conditional statements, like if a is greater than 9 and two numbers and b is less than 9, then we can use this and and we use this and, not the this ampersand and. So we have to use and, or, and not. So let us take it here. So if we have x is equal to, suppose 4, x is equal to 8 and y is equal to 4, two numbers. So if we want to use this logical operators, suppose x is greater than 7 and y is less than 5. What will happen? This x is greater than 7, it will return true, and y is less than 5, it will return false. That means this is 1 and 0, and 1 and 0 will return use 0 as the and uh, and returns 1 only if both of the conditions returns 1. So if we check it here, so first let us assign the values first, then we will check. So it will return false. Why it is returning x is greater than 7, right? X is greater than 7, 8 is greater than, y is less than, oh, 4 is less than 5, so it is returning true. What if I make it to 3? 4 is less than 3? No, it is not less than 3, so it will return false. Next we have uh, or operator. So in this case, or, what will happen, it will return true in uh, if either of the condition and statement, either this or this returns true. So whole expression will return true. And here what is happening, this x greater than 7 is returning true, so it will not check, it will not even check this expression. The moment it finds this is returning true, so it will not even check this expression and it will return true. Control enter, true. So what if I make this y is less than 3? Yeah, it is not correct, but this is correct. X is less greater than 7. It has returned 1 and it is not checking this at all. It will check only if this one, x is less than 7. So this time it will return 0, and then it will check this y is less than 3, and since in this case both of the conditions are returning 0, so it will return false. Now if I make this y is greater than 3, so this 4 is greater than 3, so this will return 1, this will return 0, again this will return 1, true. So next is we have not operator. So what not does, it just inverts the outputs. If it is true, it will make it to false. If it is false, then it will make it to true. So let us make it here, just change it here. So earlier it had come to true, so let us make it to not, and this will convert back into this true to false. So it has converted back to false. If we want to make it true, we need to do this one. So what will happen here, x is less than 8 is less than 7, it is returning false. Then y is less than 3, it is also returning false. So this whole expression will return false, and then the not, this not will make this false back to true. So it is true. Now get back to our presentation again. Next operator is identity operators. So there are two types of identity operators in Python. First is that is x is y returns true if both variables are the same object with the same memory location. So how we can check the memory location? We can check using id function. We can check the memory location using id function. So let us take it here. So we have x is equal to 10, y is equal to 10. So let us take it first, control enter. So this one is returning true. uh, these two values have been assigned. Now if we check if x is y, this if x is identical to y, or the memory location of x is same as memory location of y, so it is returning true. So how we can get to know the memory locations? So we can use id of x. This one we will execute it. So it is returning. If we check id, so it is returning the memory location of x variable, and which if we check memory location of y, you can see the memory location of both the variables are same. So that is why these two variables x and y are identical. Now if we assign some values, suppose hello, and if we assign same thing with the string, and again if we check hello x is y, it is again returning true. Why so? Let us take the memory location. So this is the memory location, and x, again the same memory location. What if I change the syntax at this time? Now if we check x is y, it is returning false. Now check the memory location, this one. Now y, check the location, memory location. So this is different now. So it is returning false. Now same way we can use some list. Suppose we assign some list here, comma this one, and I'm assigning 1 and 2 and the same value here, control enter. So the values are same. Let us check it if x is y or not. So false. Though the values assigned to x and y are same list items, but the interpreter of Python allocates these two variables different memory location. So let us take it the memory location. So this is the memory location of y. If we check the memory location of x, so this is the memory location. These two memory locations are different, so this is not returning. This is not an identity. These two are not identical. So just the opposite of this is not. So if we check is not, it will return true since the memory location is not same. And if we change here to some 5 and then again 5, so memory location becomes same, and then this x is not y will return false. So get back to our presentation now. Next is we have membership operators. So Python has two membership operators. First is in. It returns true if an element is present in the specified sequence and false otherwise. Similar to that, we have just opposite of this is not in. If it returns true if an element is not present in the specified sequence and false otherwise. So let us take it. So we need to declare some sequence variable. So x is equal to, I'm just making RTTC, and if we check a in x, so a is there present in this variable, so it will return true. And if we check not in, so it will return false. So what if I check something like this x, so this x is not present in ARTTC, so it will return true. And if we check in, it will return false. Similar to this, we can use some iterables. So iterators, I'm just making some values. This one, two values I'm just making. So here A and then B. So this X is in A, it is not present, so it will return false. If we check A, so it should return true. Now is written. If we check not, it will return false. Now get back to our presentation again. So we have seen almost this all these operators. Now we need to see the precedence of the operators. So what is precedence? If you have a mathematical expression and so many a number of operators involved, then which operator will be evaluated first? So this operators has got a precedence. So first precedence will be of this parenthesis sign, and the associativity is left to right. So we will, if a complex or if a mathematical expression is there, you have to use this. You have to evaluate first parenthesis sign, then after that you have to evaluate this exponent variable, and this you mark this. This is right to left. This is right to left. Associativity is right to left. So what does this mean, right to left associativity? So suppose we have is equal to 3 double star to the power 4 to the power 2. So how it will calculate? It will calculate like this: 4 is to the power 2. First it will calculate this one. So 4 is to the power 2 is 16, and then 3 is to the power 16. So let us change it to something 3, and I will change it to 2. So what will happen? It will calculate 3 or 2 is to the power 3. So 2 to the power 3 is 9, and 2 to the power 9. So it should calculate 2 to the power 9 equal to 512. So let us take it first. Control enter, and it is 512. What if we make from this left to right associative? So 2 to the power 3 is 8, 8 to the power 2 is 64. So what will happen if we do this from left to right? So we, if we want to calculate from left to right, then we need to do this thing. So what will happen? The first precedence will be this parenthesis sign. So this will calculate 2 to the power cube. So this will return 8, and then it will calculate or evaluate this 8 to the power 2. So it will return 64. So it is 64. Next is we have multiplication, division, then modulus, and after that we have need to evaluate addition, subtraction, then we need to evaluate bitwise shift left, bitwise shift right, then we need to use relational less than or equal to, greater than equal to. This have got same precedence. Then relational is equal to, is not equal to, then is not in, not in. So these are identity and membership operators. Then we have bitwise and, bitwise exclusive or, bitwise inclusive or. Then we have not, logical not, then logical and then logical or. So if you check here, right to left, this not sign, again the not has got right to left. So what will happen here? The associativity is right to left. So if you check here, uh, this x is less than 7. Suppose it's less than 7. So, and then I make not of x less than 7. So what will happen? It will calculate first this thing and then it will come to this part. So first it will check what is the return type of this, whether it is returning true or false, and then it will convert back. This not will be executed. So x is less than 7, 64 is not less than 7, so it will return false, and then it will again it will get converted back to true using this not. So it will return true. So in this video, we have seen about different operators in Python and their precedence among themselves. Thank you for watching the video. I hope you must have enjoyed it. In my next video, I will be discussing about conditional statements in Python. If you liked the video, then please like, subscribe and share it.